Science is something where we try to figure out what's going on in the world and try to figure out why things are the way they are. And it's a big reason I went into science myself personally. And one of the questions that people have pondered for a long time is, why is it that a freshwater pond will freeze in the winter at the same time that an ocean may still be liquid? So even though it's like below freezing out, let's say 30 degrees Fahrenheit in both locations, a pond may be completely frozen, so it's solid, at the same time that the ocean may still be totally liquid. Okay. It's a question that you could do science on. Okay, you could do the scientific method on it. Alright, so in order to solve this problem, we may use what's called a fishbone diagram, which is like a conditional arrow, except that it has many different branches to it. So there could be more than one cause for an effect. On the right, you put the effect that's occurring. So in this case, the effect is that there's a different freezing point for water, whether it's in the ocean versus the pond. I'm going to write that there's some kind of change in freezing temperature. Now, the effect is something you observe about the world that you're trying to explain, and on the left, we put the possible explanations. And there could be more than one possibility: P, R, S, and T. Now, what do you think an explanation could be for the difference? Some people propose that the salt concentration is the explanation for why there's this difference. Maybe salt water has a different freezing point than fresh water. But maybe it's not the salt. Maybe it's something else. What else is different about the ocean that you don't see with the pond? Yeah, it's bigger. Yeah, the size of the body of water could play a part. What else might explain the differences? What's that? Yeah, one's moving. Okay, so yeah, wind. You could have waves. And also perhaps boat traffic. All these are reasonable possibilities worth investigating, right? There could also be some other explanation that I didn't even mention. And the fishbone should have a ... there, showing that it could keep going if we could think of more possibilities. All right, now, there's a Khan Academy video about this topic, talking about the scientific method. And in the video, he mentions that there could be a magical reason for why the pond freezes at a different temperature. Something that can't even be observed by humans, something metaphysical, I guess. It could be a fairy. And all of these things we have to concede are possibilities. Okay, like as mathematicians, as statisticians, as scientists, we have to concede that these things are possible. To not concede that they're possible would be to have a bias, basically. We don't want that in science. One thing that was zeroed in on is the most likely explanation was the salt concentration. And so this whole process of thinking about what the explanations could be and zeroing in on one of them is one of these three types of reasoning. What type is it? Abductive. Is that what you said too? Okay, good. Yeah, this is abductive reasoning. Now, when you make an educated guess, do you know that you're right? Right, you don't. We have to acknowledge the reality that abductive reasoning is not 100% certain. Just guessing right now. Okay, let's go on to the next step. So once you've identified something that you want to investigate, you're forming what's called an independent variable. And the salt concentration can serve as an independent variable in the situation, where an experimenter could decide how much salt to put in different samples, and then they would see how the freezing point responds. And it's called the dependent variable, the thing that you are trying to influence. So at least in the video that I posted, the guy talks about, we could take a freezer and put samples of water in that freezer. Okay, where one of the samples is just normal water, and the other one could be having a lot of salt in it. The experimenter is the person who decides how much salt to put in the samples. And that's what makes it the independent variable. Now, if you lower the temperature in that freezer to, say, below freezing, 30 degrees Fahrenheit, 28 degrees and all that, then you can see what happens. Now, the act of putting the salt in the water, though, could be considered P. Okay, P means salt is added to fresh water. And then you just have to wait and watch and see what happens. What always happens is that P leads to Q. The freezing point goes down. And inevitably, every time this experiment is conducted under normal conditions, what's going to happen is the fresh water will freeze. Freezes first. And the salt water may remain liquid. So what we're seeing here is that true is leading to true. You do add salt to the fresh water, and you do observe the freezing point go down. You can do this experiment again and again. And in fact, it has been done again and again over the years. And every time you do it, P leads to Q. And so at that point, because this has happened over and over again, okay, so P led to Q, P led to Q again, and then a third time, P led to Q. You may form a general conclusion from observing several specific examples. And the conclusion to draw is that P leads to Q. And we would say that as every time salt is added to fresh water, the freezing point goes down. Now I'll ask you, is it logical to assume that this general claim is like 100% guaranteed to be true in all situations from now until the end of time, even situations that have not occurred yet? Would that be logical? Right, not 100%. You could have high confidence, and I agree with that. I do have high confidence that this is true. That in our world, whenever we do this experiment, it's going to work out that you add salt to the water, temperature, freezing point goes down. That's why we add salt to the roads. That's why you have salt that you can put on your sidewalk so it stops the precipitation from freezing and accumulating. It works reliably and always has worked. But even though we have high confidence, we cannot have 100% confidence. And this is a certain type of reasoning that we're doing when we see that P leads to Q over and over again, and we make the general claim that P always leads to Q. What type of reasoning do you think it is? Abductive, inductive, or deductive? Inductive. All right, very good. So yeah, it's inductive to make a general claim. But keep in mind that abductive is not 100%. Inductive is not 100%. There's one type that in theory is 100%. and that's deductive. Okay, but I'm going to put a star by 100%. Here's why. Deductive reasoning is something we do in our minds. It is not necessarily matched up with the real world. All right, so let's look at an example of deductive. When you do deductive reasoning, you have to start from general principles. So here's an example of deductive reasoning from the pond situation. You may assume, because you've seen it over and over again, that P leads to Q. Okay, it's called a premise or a given, it's called in a deductive argument. So it's given that every time you add salt to water, the freezing point goes down. It's never not gone that way. Then you have to have another premise. Here's another one. I have a sample of water, and I am going to add salt to it. So I'm performing the action of P. I add salt to this sample of water. The question is, can you conclude or predict what will happen? Can you form a conclusion based upon the assumptions? And the answer is yes, because when you do these types of thought experiments, you have to accept premises as absolutely true. Okay, that's the whole idea of writing them down as given or premise. So if you say that P always leads to Q, P always leads to Q, and you say that P has occurred, then what conclusion can you draw? There's only one conclusion to draw logically. Q must follow. The freezing point goes down. I hope this example illustrates how science and math are a little bit different. Because in math, we can assume that things are true. That doesn't mean in the real world they really are true, though. So, the only way we can accept our conclusions as guaranteed 100% is if the premises were. And in science, we never really know if the premises were.